Hi guys, welcome to Piece of Code and welcome to this video. And in this video we're going to continue with a crash course on OCA, and in this particular video we are going to continue our chapter that was about we were covering that methods and encapsulation, right? And we were done with methods in Java, right? And we're going to move on to the next topic, which is basically a lot of access specifiers, right? So we're going to see like all of these access specifiers in details with a lot of examples. We're going to see what are static methods and fields. We're going to see how to call a static method or a variable, what is the difference between static and instance, static variables, initialization, and about static imports. Right, so without wasting any time, let us start with this lecture. So basically we have already discussed what are access modifiers, right? Basically when you use it with a method or a variable or with a class, the type of access of that particular thing changes, right? We have learned about private, default, protected, and public. It's just like what is the boundary till which you can access that resource. That's what I mean. If you have a variable, what is the access boundary of it? If someone crosses that boundary, then that particular thing cannot access this anymore. That's what it means. Now when talking about types of access modifiers, we're going to talk about first about the private access modifier. First of all, we're going to just go through the definitions of all these access modifiers, and then we're going to dig deeper into it by some examples, right? So the private access specifier is pretty simple to understand. Only code in the same class can call private methods or access private fields. So it's pretty simple. If you have a class ABC, right, and whatever, the scope of this private access modifier is limited to the class itself, right? Pretty easy to understand. Then moving on to default or package private access. So in simple terms to understand, if you have a package ABC and inside this package whatever you may have accessible, if something is marked as default, then if belongs to the same package, in the same package whoever is there will be able to access the default instance variable or a method or a class, right? So it's kind of like private package, so it's private to the particular package itself. We're going to discuss this in detail, so don't worry about it. Let's move on to next one, which is protected. So protected access allows everything that default allows and a little bit more. The protected access modifier adds the ability to access members of a parent class. So this adds another step of accessibility, where if you have some children of that particular class, then those children, even if they're present in the different package, they will be able to access it, right? Next one is public access. Just anyone can access the member from anywhere. That's it. It's complete access, guys. So yeah, that's about all these access specifiers. Let us discuss this in detail with some examples, right, and with some demos. Let's move on, guys. So let's see an example regarding access specifiers, and it will be really fun to understand it in detail. So for example, you have a house, right? House, and your house consists of your family, and that family includes, for example, your father. Let's consider all of these as classes and this house as a package, right? And all of this are classes. So it consists of your father, your mother, and I don't know, a boy and a girl, right? Okay, actually, you know what? A son and a daughter. I don't know. I just forgot that that word at the particular moment. A son and a daughter. So this is the package, right? So let's go and do this thing, and let us understand each access specifier in detail. So I'm gonna go inside my Eclipse and gonna create one package which says house. Yeah, let's keep it simple and let's call it house. New package, and I'm gonna call it house. And in the house, I'm just gonna create a new class. I'm gonna name it as father, and I'm gonna create another class. I'm gonna name it as, I don't know, mother, and I'm gonna create another class. I'm gonna name it as son, and I'm gonna create another class let's name it as daughter. DAUGHTER. All right. So let's understand this in detail. So we have a father class, and let's say you are asking your father for some money, but the thing is your father is not giving you money. Your father likes to keep it private. He doesn't give anyone money. He likes to buy you things, but he directly does not give you money. So for example, this father has a method private void money. Okay, and the thing is, I'm just gonna keep a sys out over here and say I can spend money, or you can just say I have money or something like that, right? But the problem is that this father doesn't give anyone money, not to the mother, not to the son, or not to the daughter. But if you want to buy things, then that father is able to buy you things. So if I try to, for example, if I go into this sun.java, and if I, let's say, create a main method over here, and I say father, I'm creating a object of father class. So don't confuse it with your real father or your real mother. Okay, just gonna reference it to father, mother, and to a family. So if I try to do this thing, father dot, I don't know, money, something like that, then you can see that we are not able to access this money method, right? Because it's private. And if I just hover over it, then money cannot be resolved to a field because it's not visible over here. So that is a example of a private access specifier, right? I hope it is understandable right now. Now let us try to understand what the default access specifier. Now the father has money, that is fine, but the mother is a little bit flexible. Always mothers are a little bit I don't know, they are kind than fathers, I don't know. So your mother is kind of flexible, and she likes to give away money only to their household. I mean, only to your house people. I mean, only to the son and daughter, not to other children, right? Obviously. So mother has a method which is a default access specifier. So I'm just gonna say void money, and let's keep a sys out. I can give money to my son and daughter. So now what happens if I try to access this money method from, I don't know, daughter? In the daughter, I'm just gonna create a main method, and I'm just gonna say mother equals to new mother, and if I say mother dot money, then you can see that it is now accessible because it has a default access specifier. And if I run this class right now, if I say run as Java application, then you can see that I can access that money method from the mother class, right? That is fine, that is cool. All right, that is about the default access specifier. Let us try to test this default access specifier now. I'm gonna create another package, and I'm gonna say that is house number 2. So that will be another package. So house 2, and in house 2, I don't know, let's visualize it first. So that is a package. This is the house package we had first created, and then we have a house 2 package, for example, house 2 package, and there lives your cousin. So can you tell me if the cousin can receive money from either your father or your mother? You can guess it, right? Your father has a private access specifier, so obviously the money is only visible inside the father class. The father is not giving away money even to son, daughter, or mother, so that's completely private to that class. But your mother has default access specifier. It means that your mother can give the money to your son and daughter because that's default access specifier, so it's private to the package. But what happens if we have a different package and we want to access, or we want to get the money from your mother? Then in this case it is not possible because default access specifier is only gonna work in the same package. So if I try to do this over here, so this is house 2, and let us create a class cousin. Let us create a class that is cousin, and let's also take a main method with it. And over here, if I try to do this, right, and if I try to do this, I'm gonna say, for example, mother equals to new mother, and I'm gonna try to do this thing, mother dot money. You can see that here it is not possible to access it, obviously, because this method is not visible in the house2 package, right, because it's a default access specifier. I hope that is making sense now. Now one question may come into your minds. Yes, that is very, very important, that how are you able to access this mother class outside of house class? And if you had noticed, when I created the classes, by default it has a public access specifier, right? So this mother class has by default public access specifier. It means that this class is actually visible everywhere. So remember guys, if your class has a public access specifier, but your class components like your instance variable or your method has a restricted access specifier, then this is gonna override your class access specifier. Don't think that if my class has a public access specifier, then by default all of my components inside the class will get public access specifier as default. Your method can have private access specifier, your instance variables or your static variables can have protected access specifier. Nobody cares. Every access specifier is independent of each other, right? Keep that in mind. Alright, so cousin doesn't get the money, that is fine, that is great. But here there is another scenario. What is the scenario? Along with that cousin, there is a elder son or eldest son, I don't know. There is a eldest son who lives with the cousin. Now the problem with the eldest son is that it lives in a different house. It means that it has, so this eldest son is the son of this father and mother only, right? Obviously this family only. It belongs to this family, but the problem is the eldest son lives in a different house altogether. So it's a different package. Now the problem is that your mother cannot give the money to the eldest son if it has only the default access specifier, because at any case the default access specifier cannot exceed the boundary of this package. What is then the requirement? What can you do so that the eldest son also receives the money from your mother? Here we have to use the protected access specifier, protected, and the eldest son should extend from your mother. It's pretty simple to understand. Extend means that the eldest son must be the child class of your mother class. Obviously eldest son is the child of mother, right? So the eldest son has to specify that, okay, I am the child of this mother class, I am extending this mother class, and this mother class should say, okay, this money method is a protected access specifier or protected access modifier, because in protected access modifier what happens, it gives you a step above the boundary of your package. It says all the child classes of your class can access that particular resource, even if they are present in a different package like this one, only if they extend the class, right? Only if they are child classes of this particular class. So it's pretty simple. Now what we're gonna do is we're gonna go over here. So just leave the cousin. Cousin is not gonna get any money because he's actually not belong to that family. So we're gonna create another class over here, and we're gonna say eldest son. And don't worry about this extends keyword and everything, guys. We're gonna discuss inheritance in depth in a separate chapter. Just understand that we use the extends keyword to specify that, okay, this class is the child class of the specified parent class. So I'm gonna say extends mother. And now if I go back and if I say main method, I'm going to create a main method in this eldest son class and create the object of mother equals to new mother, mother equals to new mother. Alright, and let's do a mother dot money. Alright, still we are not able to access, because obviously if we go back to our mother class, money is still marked as default. So we're going to change it to protected, and we're going to go back to eldest son, and we're going to say mother dot money. Interesting, guys. Even though we have marked this method in the mother class as protected, and we are extending the mother class, still we are not able to access money. Now can you think of a reason? And if you got the reason, then congratulations, you have understood classes in depth. But still, whoever not got the reason, it's fine, because we have not discussed inheritance in depth. That is fine. Now let me tell you something about inheritance, guys. What happens in inheritance, that if this class, eldest son class, extends from mother class, then whatever is present in the mother class will be present in the eldest son. Obviously it comes by default. So if I want to get the money method now, I should be getting this money method from the eldest son class itself. Now it is a member of the eldest son class because it got inherited into the eldest son class. But what am I doing in this particular line, like 8 and 9? And this is also where the exam may try to trick you. In this case, it will try to trick you, because you will think that it is extending from the mother class, but still I am not able to access the money method. The simple reason is that even though you are extending the mother class, over here you are trying to create the object of the mother class, and you are trying to access the the method of mother class, and by default protected access specifier doesn't allow that. Protected access specifier only allows that method to be inherited in the child class. But if you still try to access that method using this technique, using the object of that particular class, then you will not be able to do that. Now what we need to do, we have to access that money method using the eldest son class, because it got inherited. I hope that is making sense, guys. So instead of doing this, and obviously it will throw a compiler error, so I'm just going to write it over here, compiler error. Instead of doing this, what we're going to do is, as that particular method is already present in the eldest son class, we're going to just say this dot, my bad, I'm just going to say eldest son. It's a static method, I forgot, my bad. So eldest son equals to new eldest son, and I'm going to do son dot money. Now you see, now we are able to access the method, and if I run the method now, okay, let me just run it like this, run as Java application. So you can see that method is now accessible over here, right? I hope it is understandable, guys. If you still have doubts, don't worry, we're going to cover this in detail in our in our inheritance chapter. But still, this is pretty easy to understand, that if you have a protected access specifier, right, like this, and for example if you directly try to access the particular method by creating the object, then it is not possible. If it is extending that particular class, then the protected access specifier also gets inherited, and using that we are able to access this over here. I hope that is making sense, guys. Alright, now let us understand the public access specifier. So your father actually became a little bit flexible, and now your father decided that, what, I'm gonna give away some pocket money to all of the family, including my family, which is my son and daughter, including all the cousins and everything, all of the family, because he got some money, he won a lottery or something like that. So he became a little bit flexible, and he wants to spend some money. So let us create a public void pocket money, and we're gonna do is we're gonna write a sysout over here and say take $10. Very cheap though, only giving $10. I don't know, it just came out like that. So your cousin can also get the $10 now, because it's public, it can be accessible everywhere. So if I try to say father equals to new father, and if I do, for example, father dot pocket money, now you can see that even though this is not the child class of it, or it's present in the different package, it still is able to access that pocket money method. So if I try to run this now, run as Java application, so take $10 is what the cousin gets. So guys, I hope this is understandable. Try to make it as easy as possible to make you understand the concept of access modifiers. Now the problem, the thing is, it is true for all the components. I mean, it is true for methods, it is true for instance variables also, right? And it is also true for classes. If you mark this if I mark this, I don't know, this mother class as private, then I will not be able to access it in a different package or even in the same package also, right? So it's pretty easier to understand. Now, but the thing is, you cannot mark a class as private. Gonna see this in action. If I say private over here, then it throws an error. So you can only mark it as public, abstract and final. Or if you don't wanna specify anything, then you cannot specify also anything, right? But the thing is, you can only mark it as public, I don't know, abstract, final and default. But we're gonna keep it as public as of now. See, the problem with, there is no problems with the private access specifier. If you wanna mark a class as private, if they allow it, for example in Java, and by mistake you, I don't know, mark a lot of classes as private, then it makes no sense. You cannot use that class anymore, right? Even the JVM, which is present outside of your particular, I don't know, package, right? How will JVM itself access your class, right, if it is private? So it makes sense that all of your classes should be public or default, I don't know. Final is a different keyword, so don't worry about that. But the thing is, if you have a file over here like mother.java, and it should be public now. You can have other default classes over here like class ABC, and I think I have discussed this in detail in my first chapter. Okay, so you can keep it like this, because this can be default, but one of the classes over here in the file should be public, because when you run the class, basically JVM tries to access this class, right? So it should be public over here. So that was a little nugget of knowledge that I want to give you. I hope that is fine and it is understandable. The main point of this particular explanation was to make you understand the concept of all these access specifiers with instance variables and methods. I hope that is making sense now. Alright guys, now let us move forward to a different concept now, that is basically, okay, before going to a different concept, you guys can take a screenshot of this particular table. It's like a summary of everything that we have learned. If the member is in the same class, if it is private, then it is accessible, default accessible, protected accessible, public accessible. So basically members of the same class can access everything with whatever access modifier they have. If it is in the another class in the same package, private not possible, other three are possible. Member in a super class in a different package, actually it's a subclass, sorry, it says super class over here, but it's a subclass. Private not accessible, default not accessible, protected yes, and public yes. If it is a non subclass, then basically only public is accessible, right? I mean, if it is not a child class, then basically protected will also not work, right? Only public will work in that case. Alright, I hope that makes sense, guys. Now let us move on to static keyword and let us see what static keyword does, right? So static methods and fields, right? So static methods, if you see, don't require an instance of a class. They are shared among all the users of the class, right? You can think of static as being a member of a single class object that exists independently. This is a very important keyword to understand, and of any instance of the class. Let's take this example and you will understand it better. So let me just scroll down, and for example you have a class ABC, right? And you have int A, B and C, and you have a, for example, a static X over here. Now what happens is that when you create a new ABC, right, this is creating the object of the class ABC, right? So the memory is getting allocated for A, B and C. If you create another object, new ABC, then what will happen? Another memory in the heap will be allocated for this object containing ABC. So if I make some changes over here, if I say C equals to 10, so it will not get reflected in this object. Still C will be 0 in this case, which is the default value. If I do C equals to 20 over here, then this is for a different object. This object and this object are basically different, right? This a variable and this a variable is different for this object and for this object. So when does the static variable or the method comes into the picture? Static methods and variables come into the picture when you need something to be connected to the class itself rather to the object. So what will happen in this case with the static x is that the static x will be associated with the ABC class. When the ABC class loads for the first time, the x will be given memory. That's it. It will not get the memory when the object is getting created over here, like in this case and this case. It will be common for both the objects because it is directly associated with the class ABC. So if this object tries to modify x, it says x plus plus. So the x value will be 1 in this case because this object incremented the value of x by 1. Then what happened is that this object also incremented the value of x plus plus. Now x becomes 2. So you can see that if any 3, 4, 5 objects try to access this particular static variable x, then also it's fine. It is kind of shared between all those objects. But in this case, if you see, in the case of ABC, which is instance variables, separate copies, or you can say separate memory, is associated for separate objects. I hope this thing is clear. Now, as this particular static x that you see is associated with the class rather than the object, the basic access mechanism to access the variable x is basically using the class name. So generally, how do we access methods or variables? We, for example, we create new ABC, we say ABC a equals to new ABC, and then we do a dot a or a dot b, or if there is a method a dot fun, something like that. So we use the object to access the instance variables, right? But when it comes to static variables and methods, right, we use the class name instead of the object. We do ABC dot x, that's it. So this is some basics about static, because there is a lot more to cover in static, and I'm going to cover that in a minute, but this is the basic stuff that you need to know, how static actually works and why static is actually shared between all the objects, and this is how the scenario is. Let's see some examples, guys. I hope this basic is clear. Let's see some examples. Let me go back to my workspace over here. Let me just close all of these classes and let me create a new package over here, and I'm going to name this package as, I don't know, static practice. We cannot use a keyword as a naming convention, it will mess it up. I'm going to create a new class and I'm going to name this class as counter, right? And I'm going to create a static int x equals to 0 over here. You can also make it public, I don't know, but we're going to use it in the same package, so it doesn't make any sense to make it public, so let's keep it default only. I'm going to create another class and I'm going to name it as, I don't know, driver or something like that, and let's keep this public static void main over here, and let's do this thing. So as I've told you, right, so if I do this thing, it's saved over here. So to access this variable x, what we do, we use the class name, right? That's what I said. So I do, for example, if I try to do, I don't know, counter dot x over here, if I do this thing and if I run, my god, there's some issue with my Eclipse. Let me run it like this now. So you can see the value is 0. That's fine. Now if I do, I don't know, this thing, counter c equals to new counter, and if I try to do c dot x over here, if I do c dot x, there is no issues. There is no issues over here, case. And this is where the exam will try to trick you. The rule says that we are able to access the static variables and methods using the class name, like I am doing over here, but we still can use the object name while accessing the static variable or a method. If I try to run this, then you can see the value is 0. If I try to do this counter dot x plus plus, and now if I access it, I can hope you know the output if I run this, you can see the value is 1 over here, because as I've told you, right, the static variable and methods are associated with the class itself directly, not with the I would say with the object. So if I increment the value somewhere, it will obviously reflect everywhere, right? So this thing, remember that if I do this thing and if I try to access it using the object, then it also works in this case. There is no syntax error associated with it. Very funny thing now, or a very interesting thing that I will do right now, and you will feel it like, you know, it's interesting. If I do this thing, c equals to null, basically what I did that I have assigned the reference value of c with a null value. Now generally when we do this, if we have an instance variable, for example over here, I don't know, int y, what will happen if we do, I don't know, c dot y? If you have guessed that there will be a null pointer exception, then you are probably correct. It's a null pointer exception, because obviously there is nothing, we have just cleared the heap, you can say. We have assigned a null value instead of the value it was holding, which was the object of counter class. So if I try to access the class variable or the instance variable y, then basically it will throw a null pointer exception, because basically what we did, instead of, you know, having this abc, we just removed it, we just assigned null to it. So currently there is no abc, you can say. Now if I just comment this out, another interesting thing will happen. If I run the code, then you can see that there is no null pointer exception. Here there is no null pointer exception when we are trying to access the static variable. Pretty interesting fact, because see, as I've already told you, that a static variable or a method that you see, it is not associated with the object, it is associated with the class itself. So even though you have assigned a null value to your object, it should not affect your class, right? Your class is as it is over here. When your class is loaded, I have told you, when a class is loaded, the static variable or methods will get the memory. It will not get the memory when your object is actually loaded or when you create the object. Only your constructors, your instance variables and your instance methods are associated with your objects, not the static methods and the variables. So using that particular approach, you can probably guess that even though we have assigned a null to this object, still we are able to access the particular static variable, because it is basically doesn't associate itself with the object. And this is also where the question, you know, the exam will try to trick you. They will say that there will be a null pointer exception in the option, but you shouldn't select a null pointer exception over there, right? That I hope that is clear as crystal now. I hope you can work with, I don't know, methods. Methods also is the same thing. If I do, for example, public static, I don't know, get counter, and if I say, for example, public static int, and if I say return counter, then it's the same thing, right? Oh, it's x. If I do this thing, then it's the same thing, right? If I do, for example, counter dot get counter, then it's the same thing, right? You use the same the same technique to access methods also. Now let's see some interesting facts about static methods, guys. Okay, the first fact, if we try to access a non-static variable inside a static method, let's see what happens. If I do a sysout over here and I try to do this thing, you can see there is a compiler error which says cannot make a static reference to a non-static field. So compilation issues. Keep this in mind, guys. I'm going to give you a very simple explanation to why this phenomenon happens. If I go back to our diagram, right, this x is associated with your class. Before I load my object, do you think that here the object has been loaded as of now? Did we create an object inside the static method, or we did something, right? We didn't do anything. We didn't create any object as of now. So this y has not been associated with the object till now. And if you see, the static methods and variables get the memory when the class itself gets loaded, and we haven't even created the object as of now. So that is why you can see that the y that you see over here, it's basically for this method y doesn't exist as of now. You can think of it as, now that is not exactly what happens there, but you can think of it like this: y actually doesn't exist for the static get counter method. That's why there is a compiler error over here. I hope that makes sense. And another fact is that these are instance variables, and these are associated with the object, and these are associated with the class. So this cannot access this particular instance variable y over here. So I hope that you should keep this in mind, because they may try to trick you in the exam. Let's see another pretty simple thing. Obviously, by this fact you know that static methods can access static variables. That is pretty much of clear as to it as of now. Let us see this particular example. Let's create another method, public void something or fun, and let's try to access this, I don't know, x over here, which is a static variable. Now see, this thing is not possible, but the vice versa, I mean accessing a static variable inside a non-static method is possible. And you can relate to the same concept that when this object gets the memory, for example this instance variable instance method gets the memory or it is visible, the static variables are already visible because it got loaded when the class itself loaded, so it got the memory first. So for this particular method, this fun method, x already exists. It's just the opposite of what we saw over here in this method, right? So for this method, fun method, x already exists because it has been loaded with the class counter. I hope this thing makes things too clear to understand. I don't know what I'm saying at this point, but still I hope this thing is clear. So the takeaway to this particular thing is that you can access a static method or a variable inside a non-static method or a method, but the vice versa is not possible. If I try to access a static variable inside a non-static variable inside a static method, then it is not possible. And the exam may try to throw you off using this concept a lot. So you must be careful about this concept, guys. Right? I hope that makes sense, guys, because it is very, very important to understand. Right? Now let us go back to our slides for a minute. And also, guys, one thing keep in mind that the counter is a very a very popular question in the exam. What they do is they try to create three objects. Driver. They will try to, for example, say counter C equals to new counter, right? They will try to do this thing. They will they will try to give you like 3 or 4, so C1, C2, C3. So they will do C1 dot x plus plus, right? And then they do C2 dot x equals to 0. Then they do, for example, C3 dot x plus equals to 2, and then at the end they will do, for example, counter dot x plus plus, and at the end they will say sysout. So these kind of questions they try to do to make it look a little bit complicated and a lot bit complex. Then they do, for example, they just display like counter dot get counter. If I run this code, you can see the value at the end is 3. Alright, whatever. The problem, the fact is that at this point the value of counter was 1 after this lines of code. When we print it over here, right, we get the value as 1, right, over here. Now here C1.x plus plus happens, so the counter is incremented to 1 again. I mean it says 1, Then what we do is basically we increment the we set the value of that counter, which is x, to 0, so it becomes 0. Then we increment it by 2 over here, so it becomes 2. I hope you are getting it. And then at the end we say counter dot x plus plus, we increment the value of counter again, so it becomes 3. So then we get counter dot get counter and we get 3 as the output. I hope that is clear, guys. So basically after this point it becomes 0, and then we say 2, 0 plus 2 is 2, right? And then we increment it again by 1, which is 3. Then we say counter dot get counter, which is 3 in this case. So see, don't get confused, guys, if you see a lot of static over here and there and a lot of stuff happening here and there. Basically it's the same thing. And one very a brain nugget for you that I want to throw at you is basically why the main method is static, right? And also why it is public, and also why it is void. Probably you guys know all of these things by now because we have covered this in the last lecture and this lecture. So see, the main method is basically the starting point or the entry point of your Java application or a Java class, where your JVM searches for that main method, right? It particularly searches for the main method. As the JVM searches for the main method, guys, it has to be public. And I've also given you this hint previously in this lecture only. If it is not public, JVM is present outside our package, even outside of our project also. So basically if this is not marked as public, then how will JVM find this main method? So that's done. That's why it is public. Now coming to static, as I've already told you that a static method or a variable is associated with a class. So we can say class name dot that particular method name or the variable name, like that static method or variable. We can do that. So the JVM doesn't create a object of the class. Alright, it directly uses the class name, which is driver, to get this main method, which is static. That is why it is static over here. Now why it is void? Basically you know return types of a method, right? And in return types of a method, you know that basically if it is void, then the method returns nothing basically. So in this case it returns void. So that is why, what will the, if for example we return an integer variable from here, what will the JVM do with the returned value? It just runs the particular main method, right? It doesn't need that return value. So that's why it is void. And it is main because obviously the name of the method should be main. Otherwise if you name it something else, it will not work because the JVM particularly searches for the main method. Alright guys, so I hope this information is useful to you. In some interviews also they ask you this question, so I hope that this will make sense to you now. Alright guys, so that was about static. Let's cover some more concepts now. So let us also see one more table about I don't know, static methods, guys. You know, this is table, you can take a screenshot. You can remember, like if it's a static method, then if another static method or variable is calling, then basically it is legal. If it is a static method, if another instance method or variable it is calling, then it is not legal, right? If it is an instance method and it is calling, for example, a static method or a variable, then it is legal. We have saw this particular you know, example just now, right? And if it is an instance method and it's calling another instance method, and basically it is legal, right? That's particularly what I meant to say. Alright, so that was the basic things about static, guys. One more thing I want to talk about static is sometimes we can have final keyword associated with it. So basically when a variable is marked as final, then basically what happens is that you cannot override it again. It just means that it becomes a constant, right? So if I have another variable and if I mark it as final, static final int, I don't know, count equals to 10. Now if I try to do this thing over here in the static method, I go and say count equals to 20, then you can see that it says the final field counter cannot be assigned. And sometimes in the exam they may give you like this, they may give you multiple, you know, static variables and there is a final method over here, and then you can get confused at that point. So make sure you always look for that. And also if I go in the driver class and if I try to do counter dot counter dot count equals to, I don't know, 30, then also it will throw an error because that count is final. So even if I try to do it like this also, it will throw an error. I hope that is clear, guys. Right, now let us talk about static initialization. And if you remember from our chapter 1, where very much time back when we started discussing about this Java building blocks chapter, we covered instances initializers that look like unnamed methods, right? So it looked something like this: static, caps lock, static, and this is how static initializers look like. So we also talked about normal initializer blocks with just without the static method. When we add a static keyword to it, basically it becomes a static initializer block. So basically, what does this specify? When we add the static keyword to this initializer block, we just specify that they should be run when the class is first used. Basically the same formula that we use with static methods and variables. When the class is loaded first, all these methods are loaded first. So static initializers are loaded before any constructors or normal initializers, right? That is the hierarchy how it goes, or that is the sequence how it goes. So if I write something like this, int x equals to, not int x, int z equals to, for example, 20, and if I say for example x equals to 30 or something like that, and if I try to, for example, say count equals to 30, then you see that is still the error occurs. So basically, even if you try to change the value of this count, final count, in the static block also, still you are not able to do it. But you can initialize a final variable inside a static block, so you can do that, whatever. So the static initializer, I don't know why my tongue is slipping, it's a tongue twister. Is it an initializer a tongue twister? No, it is not a tongue twister. The static initializer basically runs when the class is first used. Alright, whatever statements you write in it run and assign any static variables are needed, right? Whatever I have written over here, it is executed, and whatever assignments I make over here, it gets assigned. But there is something interesting about using the static initializer blocks. Basically, I've told you, right, that final final constants that we saw over here, it cannot get reassigned, and if we do this thing, then basically it is not possible over here, right? So if I try to do this, and if I try to, for example, do this particular thing, static final int count 2 equals to 20, and if I try to do this thing over here, count 2 equals to not this thing, sorry, let me just remove this, and if I do this thing, then it works over here. So you can get confused at this fact that I am reassigning the value of count 2, which is a final variable. We just discussed that final variables are constant and cannot be reassigned, and we are reassigning it over here, right? So basically, why it is happening like this? The basic simple fact is that we are not assigning anything over here. The first assignment is actually happening in the static block. So it is perfectly normal to see this kind of questions in the exam, and they may ask for a compiler issue, option over there. You do not go with the compiler issue over here, because there is no compilation issues over here, because the first assignment actually happens in the static block itself. But if we try to reassign it over here, like we saw in the case of count, if we try to reassign it like 40, then it is not possible, because the final field count 2 may have already been assigned. So you can see that we cannot reassign it. But this thing is perfectly normal. So I hope you do not get confused in the exam about this. And also a very brain nugget for you guys, very simple brain nugget. Avoid using static and instance initializers and normally in your development life, because it will make your code very hard to read. Just think about it, how easy it is to read it like this, how hard it is to read it like this. Because I am declaring the final variable here and I'm assigning it over here in the static block. So it becomes a little bit difficult to read and understand. That's why it's a common practice to not use it in your day-to-day lives, but you should know about this, because if you are appearing for an exam or an interview, they may test you on this particular concept. So I hope that is clear, right? Alright guys, so let us talk about static imports now. Now in chapter 1, in our very first chapter, we have learnt that we could import a specific class or all the classes in a package. We can do like this. We can do, for example, we can do import java dot util dot dot array list, right? And we can also do import java dot util dot star. Star is just a wildcard. It just means that we are able to import everything in that particular class, in that particular package. Sorry, my bad. This is also completely fine. And imports are convenient because you don't need to specify where each class comes from each time you use it. There is another type of import that is known as a static import, right? Regular imports are for importing classes. Static imports are for importing static members of classes. There is a difference, because there is no concept known as a static class. There are static members. We just discussed that. There can be static methods or static variables, but no static classes. So when we do a static import, we basically refer it that importing members of a particular class. So what is the advantage of this? The advantage of this is basic, that when we want to access a member of a static member of a class, we use the class name dot the particular member name. So if you are using it like 20 or 30 times in a code, then it becomes pretty much of exhausting to always write the class name. So if you import it from the class, then basically all the members are imported at once and you can directly use it in your code, right? Now let me give you an example. And we have talked about array lists, right? So we can use that as an example. So we can just say, for example, so there is a method in arrays that is known as list, and if you remember, it converts it to a fixed size list, right? It converts a series of elements into a fixed size list. So it goes like this. So arrays dot as list, right? And then we specify like this. So what we do, this is a static method, guys, and it returns you a list, right? It returns you a list. Let me just create that list, assign it to a new local variable. So you can see that's a list over here, and we use the class name dot the method name. That's how it goes. But we can do it like this over here. If you see, it's pretty simple. We can just say import. We have to use the static keyword now because it's a static method. Import static java dot util dot arrays dot as list. Now if I remove this arrays dot from over here, then it also works. We just have to say as list because I have imported this method from the arrays class now, right? And in this example, what we are doing is specifically importing the as list method. Now an interesting case, and it is pretty much from my exam perspective, is that what would happen if we created an as list method in our in our particular driver class. For example, we create an as list method of our own in our particular class. So what happens in that case? Because it will have the same name as this particular as list that we are importing from the arrays class, right? What will happen in this case is that Java would give preference. So Java will give that local method preference over the imported one, right? And the method we coded would be used instead of using this method, which is used in this case. The method that we will create will get used. So I hope that makes sense over here. And what is the how do we access this as list then? In that case, we have to use the class name dot as list. In that case, we have to use arrays dot as list so as to differentiate between those two as list method. Because we can also create a as list like this, right? We can say public static I don't know, list integer, I don't know, integer as list, like this, right? And this is a method. It's perfectly fine to create a method like this. For now, just let us return null. So in this case, when there are two as list methods over here, we have to use it, use arrays.asList to differentiate that, okay, we are using this as list method from the arrays class over here. That is making sense. All right. Now, there is one more scenario that I want to discuss, and let us go back to our this one note to discuss the scenario. If you remember back in chapter number 1, we learned that importing two classes with the same name gives a compiler error, right? And if you remember, we took the usage of the date class. There was a sql.date class that we had tried to import, and there is a util.date, right? And we also saw techniques how we can resolve the issue if there are both the same name. And there is also the same name in static imports also, but it is not classes, but it's members now. So if there is a case like this which says import static, I don't know, there's a package called statics, for example, .a, this is the class .type, right? There is this thing, and we have another static import which says import statics.b.type. What will happen in this case? This will throw a compiler issue because both are the same. So this is also true of static imports, because the compiler will complain that if you try to explicitly do a static import of two methods with the same name, or I don't know, two static variables with the same name, and there will be a compiler issue in that case. But luckily, when this happens, we can just refer to the static members via their class name in the code instead of using a static import. Basic thing is that, like we saw it in this particular example, right? If you have the same method name over here, it's the same scenario over here, right? Just same name but from different classes. So basically we refer it using the class name itself, right? We do not do two method imports or two variable imports with the same name. We use the class name as a differentiator, like arrays.asList, to differentiate from this asList method for in the example. Alright guys, so I hope this thing is pretty much of clear to you guys, and this was very, very important to discuss from an exam perspective and also from an interview and from your day-to-day coding life. So yeah, that's it for this lecture guys. We're gonna continue with our chapter in our next lecture, right? Till then, have a good day. Bye bye.